Securing billions of dollars in physical assets, from sovereign bullion to private antiquities, currently relies heavily on cloud-connected infrastructure. That connection creates structural vulnerabilities, including remote hacking, malicious network spoofing, and macrogrid reliance. External dependencies now dictate internal security. This graph shows how insurance actuaries process these blind spots. They are forced to calculate for unverifiable risk, mapping the expanding frequency of network vulnerabilities directly to exponential increases in premium costs. Pouring thicker concrete and installing heavier vault doors does not lower those premiums. Risk ambiguity is only eliminated through mathematical, verifiable digital certainty. The Sovereign Fortress Asset Protection Package is engineered specifically for high-net-worth collections and bullion depositories to provide that absolute certainty. It operates as an impenetrable, localized AI operating system that is designed to completely replace external cloud dependency. The architecture shifts computing entirely to the edge, keeping all data inside the facility walls without a single byte ever leaving the building. Edge computing is a distributed IT architecture that processes client data at the periphery of the network, as close to the originating source as possible. By isolating the compute power, the system transfers security from a hackable external cloud directly to a mathematically verifiable physical edge. The brain of the facility consists of two air-gapped Sentry Pro GPU clusters, isolated deep within the primary secure data center. Their primary computational function is rendering a perfect real-time 3D volumetric digital twin of the entire vault. A digital twin is a highly precise, continuously updated virtual replica of a physical object or environment. During Phase 1 deployment, the system generates an offline root CA to establish localized trust. A root certificate authority, or root CA, is a master cryptographic key that signs and authenticates all other digital certificates within a closed network. This offline root CA cryptographically connects over 260 edge sensors and physical nodes without ever pinging the external internet. The facility now possesses a localized autonomous intelligence that requires zero external connectivity to coordinate its own physical security. The sensory inputs for this intelligence are 50 Vault Warden LiDAR modules mapping the facility continuously. LiDAR is a remote sensing method that uses pulsed laser light to measure exact distances and generate three-dimensional spatial maps. These modules sync the exact physical location of authorized personnel and high-value assets directly to the 3D digital twin in real time. The active defense parameters are absolute. Any unauthorized volumetric shift greater than 2 millimeters in an asset's position is instantly flagged by the system as a critical anomaly. The response requires no human input. The industrial foreman system drops 12-volt magnetic locks across the entire facility in under 15 milliseconds. Physical blind spots are mathematically eliminated when the entire three-dimensional volume of a vault is tracked at a sub-millimeter level. Tracking an object's location solves only half the problem, as location data is useless if the physical object itself has been swapped for a visually identical fake. To counter highly sophisticated physical forgeries, the system deploys 20 high-resolution multispectral PTZ cameras. PTZ stands for Pan, Tilt, Zoom, which allows the camera lenses to mechanically adjust their spatial orientation and focal length. These cameras execute a process called spectral provenance, actively scanning the molecular density of bullion and the specific weave patterns of canvases to identify materials. The local AI routines compare these real-time multi-wavelength scans against a pre-recorded baseline golden state signature captured when the priceless asset first entered the vault. If a physical discrepancy is detected, the system immediately triggers a ledger burn. A ledger burn is an irreversible cryptographic function that permanently marks an asset's digital profile as compromised and untrusted. Thieves cannot bypass the security architecture with clever visual replicas because the system confirms authenticity at the molecular level. To manage operations without opening external network ports, internal communication runs through a private 5G canopy comprised of 30 Nomad forge points. This guarantees signal integrity even deep inside Faraday-shielded vaults. A Faraday-shielded structure uses conductive mesh or heavy metal plating to block external electromagnetic fields and signals. This canopy extends to external logistics via 10 Nomad fleet kits, which plug directly into the CAN bus of incoming armored transport trucks and internal AGVs. The CAN bus is the internal communication network that controls a vehicle's electronic systems, while AGVs are automated guided vehicles used to transport heavy loads without a driver. Incoming armored trucks digitally handshake with the vault perimeter, automatically opening exterior gates and dispatching internal AGVs to retrieve cargo, using dead reckoning. Dead reckoning is a navigation method that calculates a vehicle's current position by advancing a previously determined position using known speeds and precise directions, requiring no GPS signal. This secure cargo transfer executes entirely through machine-to-machine handshakes, removing human interaction and eliminating logistical vulnerabilities at the loading bay. The system also monitors the object's physical environments. A grid of 150 industrial micronodes continuously logs hyper-precise climate data, including relative humidity and biological spore counts. These micronodes run on independent battery backups, guaranteeing that climate-sensitive antiquities can be actively monitored, even if an attacker intentionally cuts the facility's main HVAC and power grid. The Sovereign Fortress integrates these protective measures to secure assets from every operational angle, linking armored transport routing directly to localized biological preservation. The most dangerous vulnerability in any secure facility is the authorized insider, such as a rogue vault manager attempting to manually alter the digital twin to hide a stolen asset. The architecture prevents this by ensuring the digital twin's core audit logs are strictly immutable and mathematically impossible for a single user to alter. Manually overriding a missing asset alert requires a multi-sig ledger architecture, demanding simultaneous cryptographic authorization from the client, the integrator, and the insurer. Multi-signature technology requires multiple independent cryptographic keys from different parties to authorize a single system action. If attackers abandon software manipulation and attempt a brute force physical extraction of the central Sentry Pro GPU server, the hardware itself reacts. Internal gyroscopes trigger the volumetric chassis defense upon detecting unauthorized physical movement, permanently encrypting the NVMe drives and securely purging RAM in milliseconds. NVMe drives are high-speed solid-state storage devices that hold the system's core operating data. The physical infrastructure relies entirely on internal cryptographic math, making it structurally immune to both physical brute force tampering and high-level insider corruption. All of the facility's localized data, the LiDAR maps, the spectral material scans, and the climate readings, must be synthesized into a format that proves the security state. This massive influx of edge data is processed locally by the Ledger Bridge daemon. A daemon is a background computer program that runs continuously to handle system tasks without requiring direct user interaction. The daemon outputs a continuous, immutable proof of existence cryptographic heartbeat for every physical asset inside the vault. The sensors translate chaotic physical reality into pure, immutable cryptographic truth, recorded entirely on local hardware. This localized truth directly solves the actuarial problem of unverifiable risk. This diagram shows how underwriters are granted access to a read-only, zero-knowledge proof API generated by the local ledger. A zero-knowledge proof is a cryptographic method that allows one system to prove a specific statement is true without revealing the underlying data. Through this specific API, the system verifies the absolute safety and physical condition of the assets without exposing their physical location or requiring access to a centralized cloud. Because human error and external cloud hacking are mathematically eliminated from the risk pool, underwriters offer massive multi-million-dollar premium reductions. Ultimate asset protection is no longer achieved by pouring thicker concrete. It is achieved through localized computational sovereignty and mathematical verifiability.